Hello everyone, my name is Adarsh Devedi and today I am going to present on topic emotion recognition of speech based on RNN. It is based on a IEEE paper by Chang Woon Park, Dong Wook Lee and Kui Bo Sim. Over the previous years, the role of machine has increased rapidly. For a robot to interact with humans, it is important that he has an understanding of emotions. Because of this, emotion recognition has been a prime research topic over the previous years. Humans can recognize emotions by several ways. For example, a boy's expression can simply be understood just by looking at his face. And when people talk to other on the phone, they can easily understand their emotions just by hearing them. Of the several ways, speech is used as an element of emotion recognition. There are several methods to analyze speech data, for example, formant, pitch, LPC, and more. Here we'll be using pitch as the primary feature to understand four basic emotions: normal, anger, laugh, and surprise. Parts. Consonants and vowels. Vowels consist of quasi-periodic waves. The time period of these waves is called pitch. Pitch mostly depends on the variations of emotion. Its features are defined for different emotion and in multiple patterns. For example, a pitch of an angry voice will have many sharp rises, whereas a person who is laughing will have a periodic multiple amplitudes. Here we'll be using only one pattern for every emotion to train a recurrent neural networks. Our RNN is a two-layer network which has 7 nodes. It has one node in input layer, 2 nodes in hidden layers, and 4 nodes in the output layer. Now let's see how the waveform of these emotions look like. In each figure here, the top diagram shows the waveform while the bottom one shows the spectrum. As we can see here, the normal emotion has the simplest pattern and has a plain pitch contour. When people get angry, they start speaking in a low voice. Some start shouting in excitement. However, the pattern we select here is the shout type. If you look at the figure, the characteristic rise and fall in the end shows the stress part of shouting. For laughing, we select a broad laugh like ha ha ha. This type has a periodic presence of vowels and the amplitude is lowered gradually. When people are surprised, their linguistic central nerves paralyze. Because of this, they can't speak sentences and respond in shout scream to surprises. Now let's talk about how we should pre-process a speech data to be used as input to RNN. Pitch is the fundamental frequency of speech signal and is one of the most sensitive parameter for hearing sense. Unlike regular sampling data, speech data is a sequence of time series data. So, we use an autocorrelation function which tells us the correlation between points separated by various time lags. Pitch on time axis is represented by an autocorrelation function. The autocorrelation function for discrete time is given by equation 1, whereas for random and periodic function, the autocorrelation function is given by equation 2. In these equations, k represents the time period. If the value of k is equal to the period of pitch, then the magnitude of correlation will be larger than any other value. This means that the speech signal does not only have pitch information but also a lot of other data. So, to filter out the useless information, we use a clipping function. Here, y of n represents a clipping function where the resulting data will be free of any distorting information and can be used as an input to RNN. Now let's talk about the structure of our model. The input here is the result of the clipping function. The received input is then passed through a feature extractor, which extracts the useful information and stores it in the database. At the same time, the extractor provides these features to the training model, which generates the best individual weights for the nodes. Then after the creation of model, we can recognize emotion by passing the speech data to the model through the feature extractor. Now let's talk about RNNs. RNN stands for Recurrent Neural Networks. Recurrent neural networks are a type of neural network designed for capturing information from frequency or time series data. RNN has internal state feedback and self-feedback and deals with the inputs non-linearly, that it shows dynamic characteristics and is useful to problems having sequential data. Now what we see in the figure here is a generic model of a single unit of RNN. It has an input X and a result Y. The RNN node holds the information of the current state of the time sequence. It is the result of the function which takes the previous state and the current value as input. The current state is then passed on to the next RNN node for doing the same computation on the next time sequence data. A way to look at it is that each state is like a memory which contains the information about everything in the past. This value of state is got using the formula h of t equals fw with inputs at ht minus 1 and xt, where h of t is the value of the current state, fw is some function with parameter weights, ht minus 1 is the previous state, and xt is the input vector at some time. This is the combination of many such units of RNN, where x is the input of time sequence data at different periods of time, ht is the node state at that time, and y is the result. As we see here, the state from time t1 is passed to time state at time t2 for providing the computation. The forward propagation computes the result y of the complete time series data and finds the loss. This loss is then propagated back through time to compute the gradient and update the weight parameter. The RNN used here is a fully connected network. Has one node in the input layer, two nodes in the hidden, and four in the output layer. The input is the pitch and the result is the class of emotion. The output of the ith neuron is y of t is f of ht minus 1 plus lambda sigma, where h of t is the summation of wij, yj of t plus xt. Here hi of t minus 1 is the net input at the ith node at time t minus 1. Xi of t is the external input at time t. F of x is the node function which is tan h of x by mu naught. Lambda of sigma is the Gaussian random number with zero mean and sigma standard deviation. The evaluation is made by handling of difference of goal and the result gained from the RNN. Let's assume the goal as input vector minus 1, minus 1, minus 1 and 1, and the result be minus 1, minus 1, minus 1, 1. We compare the goal with the result bit by bit. If the difference is over 1, a penalty is incurred which is equal to the difference multiplied by 3. This penalty function is given as follows. This paper shows emotion recognition using RNN. It proposed the pitch as an important element for emotion recognition and for recognizing sequentially inputted data. This paper used RNNs. Evaluation module used a penalty routine, and this method was relatively relevant. But this routine should be improved for faster researching. Thank you.